Hello guys, welcome to my channel. So in this video we'll discuss about the concepts of K-map. Okay, so in the previous video we discussed about the duality theorem and different Boolean laws, okay, associative, commutative, distributive law, and also the De Morgan's theorem with examples. Okay, so in this video we'll discuss about the K-map method. Okay, K-map. So here we have simplified the Boolean functions using the Boolean postulates and theorems. Okay, the laws and theorems, and it is the time consuming process. Okay, as we need to apply the theorems and all, it takes a time, and we have to rewrite the simplified expressions after each step. To overcome the difficulty, Karnaugh map. Okay, Karnaugh or K map. Okay, Karnaugh map. Karnaugh, or we can call it as a K-map, is a method for simplification of Boolean functions in an easy way. This method is known as Karnaugh map method or K-map method, and it is a graphical method. Okay, graphical method which consists of 2 raised to n cells for n variables. Okay, if there are four variables, then how many cells in the graphical representation? 2 raised to 4, that is 16. Okay, if there are three variables, 2 raised to 3, there are 8 cells. Okay, so this is about the Karnaugh map and K maps for 2 to 5 variables. So here are the some example of 2 variable and 1 variable. 2 variable, this is the way. Okay, and the y and z are the 2 variables. Okay, so here y variable means it is either 0 or 1. Okay, 0 or 1, and this variable either 0 or 1. Okay, there is only one possibility of grouping the 4 adjacent min terms. The 2 variable K map is there are 4 cells. Since the number of variables is 2, the figure shows the 2 variable K map. Okay, 2 variable K map. The possible combination of group 2 adjacent min terms are, okay, the min term adjacent, like for example here this min m0, this term it is adjacent with m1, and m2 it is adjacent with m3. Okay, and m0 is adjacent to m2, and m1 is adjacent to m3. Okay, so these are the possible combination of the two adjacent min terms. So 3 variable K map, this is the how we can write a 3 variable K map. Okay, there will be 2 raised to 3 means 8 cells. How many? 8 cells. Okay, x here the x variable and y z. So what are the options? 0 0 0 1 1 1 and 1 0. So total 8 cells, right? Now there is only one possibility of grouping the 8 adjacent, okay, min terms. So the for 8 adjacent, okay, 8 adjacent min terms means it is one possible, and for grouping the 4 adjacent, okay, so here in this case, okay, in this case, suppose if I this is for the 4 variable adjacent, if I can group in one way, this is second way. Okay, then I can take m1 m3 m4, this is also one way for grouping. Okay, and another is these two and these two. Okay, likewise there are 4 ways we can make a grouping. Okay, so that is the one way, and for 8 that is for 4 variable. Okay, so for 4 adjacent variables there are 4 terms we will get, and for example For 8 terms there is only one term we'll get. Okay, then for example for 2, okay, for the 2 variable, for example if I adjacent these two terms, okay, 1 2 3 4, these are the options. Okay, and also like I can cover in this way also. Okay, these two. Okay, so likewise here the possible of combination of group 2 adjacent minterms are, so these are the various of mint, like 8, 1 2 here, 3 4 5 6 7 8 9 11 12. So there are 12 possible combinations. Okay, if x is 0 then 3 variable k map, it becomes 2 variable k map. Means if the one term is not there, then it is 2 variable k map. Then for 4 variable k map, so this is the how we write for 4 variable k map. Okay, for 4 variable k map you need to write a square box, okay, to make it into different cells. Total there should be 16 cells, right? Suppose if I use a b c d, two variables, so here the options are 0 0 0 1 1 0 1 1 0 0 0 1 1 1 1 0. Okay, so this is 0th cell 1, this is second cell, third cell 4 5 6 7, and here it is 1 1. Okay, so actually this is the we need to write like this way. Okay, so this is 8 9 10 11 12 13 14 and 15. Okay, in this way we need to write a 4 variable k map. So this is the one possibility. There is one possibility for grouping the 16 adjacent. These are the min terms. Okay, these are the min terms, and there is a one possibility for 16 adjacent min terms. And R1, R2, R3 and R4 represents the min terms of the first row. Okay, first row, second row, third row and fourth row. Okay, like for example, let us discuss R1 and R2. Okay, here suppose if I group this one, this is the one combination of terms and this is another term possibility. Okay, and there is also possibility like this is the one possibility of grouping for 8 terms. Okay, and this is the one more possibility. Okay, so in this way okay, once we solve the problem you can understand. For 5 variable 2 raised to 5, that is 32 cells. Okay, 32 cells for the 5 variable k map. So there is only one possibility of grouping the 32 adjacent min terms. Normally you won't get in the examination for the 5 variable and all. Okay, now we'll discuss about minimization of minimization function using the k map, minimization of the boolean function using the k map. Okay, so here once if we consider the combination of the input for which the boolean function is 1, then we will get a boolean function which is a standard sum of the product, SOP, standard sum of the SOP form after simplifying the k map. Okay, standard product terms will get searched. Okay, and if we consider the combination of the input for which boolean function is 0, then we will get an boolean function which is in the POS form, product of sum. Okay, if we consider a boolean function with 1 means SOP, and if we consider a boolean function with 0 means that is a POS form, product of sum form. Okay, and there are some rules are there for simplification of boolean expression using the K map. Okay, select the respective K map based on the number of variables present in the. Okay, so as we know, just now we discussed for 2 variable the graphical representation is different, for 3 variable graphical representation is different, 4 variable is different. So you need to select the appropriate the graph based upon the number of variables. And if the boolean function is given as sum of the min term form, if the boolean function that contains the min terms, then place logical ones. Okay, place logical ones at the respective min term cells in the K map. If the boolean function is given as sum of the product form, SOP form, then place the ones in all the possible, okay, sum of the product. For example here, okay, sum of product, SOP form, SOP form, sum of the product. Check the possibility of grouping the maximum number of adjacent one. It should be a power of 2. Start with the highest power of 2 up to the least power of 2. Okay, then each grouping will give either a literal or one product term. Okay, it is known as prime implicant. Okay, so here we'll discuss with one example. If the outputs are not defined for some combination of the input, then the output values will be don't care. Means so in the don't care, it means you can consider either 0 or 1. Okay, in the don't care you can consider either 0 or 1. Okay, don't care, where the combination of input. Okay, if the outputs are not defined for some combination of the inputs. Now let us take one example here. Okay, so this is the one example. The x, there are 4 variables are there. Okay, so just I will put this in the new page. Okay, so I will enlarge this one. Now I will place here. Now here we need to solve this by using the K map. So how many variables are there? There are 4 variables. So 4 variables means that are w, x, y and z, right? So 2 raised to 4 means how many cells? 16 cells. 16 cells are required. Okay, so now what I will do is I will draw a table, means the graphical representation for this 4 variable K map. Okay, so here this is the K map. Okay, so okay, now what are the variables? Well, the variables are w, x, y, z. Okay, I will I will give the label 0 0 0 1 1 1 and 1 0. You need to remember this one, 0 0 0 1 1 1 1 0, right? Now they are given the 3 terms. What are those? W, x bar, y bar, and w, y, and w bar, y, and z bar. Okay, so here with these 3 terms, okay, like for example, in w, x bar, y bar, okay, one term is missing. What is that? Z. So this we can write like this, z plus z bar. Okay, so here the given boolean function is a sum of product terms. If product terms are given, it is having 4 variables. Okay, so we require 4 variable. The K map variable ones correspond to this product terms are shown in the figure. Okay, so here one is placed in the following terms. The cells which are common to the intersection of row 4 and column 1 and 2 are corresponding to the product term. Here w x bar y bar. Okay, so here this particular term, okay, so here this particular term, so this is also equivalent to this one. Okay, here w x bar y bar z plus w x bar y bar z bar. Now here w and x bar means what? Here it is a 1, here it is 0 0 1, here 1 0 0 0. Okay, so w x bar, so here the 1 0 1 0 means here this is the fourth row. Okay, so here it is 1, this one term is there, w x bar and y bar z means 1 0 0 and 1 0 1. Here these are the two terms, that is min terms are present. Okay, we have covered both 1 0 0 1. Okay, here it is 1 0 and 1 0 0 1. Okay, the next is 1 0. Okay, the row and column. Okay, so here it is for, this is for 1 0 0 1. So this is the logic one, and this is for the 1 0 0, right? Similar to for this also w y. So w y means here x and z are missing. Okay, so what are the options? You will get four options here. 1, w is 1, x we don't know. Okay, so we need to consider either 0 or 1. Okay, then y it is 1 and z we don't know, means 1 or, so likewise here we need to think 1 0 1 0. So here there are this for x also, for x means with respect to this one wi, w is 1 and y is 1. Okay, z is here x and z are missing. Okay, x and z are mixing, means these are missing here. So, or if you are getting confusion, what you do? Okay, so yeah, so yeah, I will take here wy means the missing are x plus x bar and z plus z bar. You that indicates one only. Okay, so now wyx bar wyz wy. Okay, so yeah, okay, sorry, here you need to find, first you need to find for the product terms. Okay, means w into y, here x into z plus x z bar plus x bar z plus x bar z bar. Okay, so in the bracket I removed that one. Now w y x z plus x z wy x bar z plus wy x bar z bar. Okay, now this is the terms where this is the four terms. Okay, now here what you need to write, w y means 1 1 1 1, here 1 0 1 1 1 0 1 1 1 0 0. So here 4 times 1, 4 times 1 means which one? This is the term. Okay, here you need to write 1. Okay, so likewise you consider for these 4 terms. Okay, so in this way you need to write 1 0 1 1. Okay, 1011 means this particular. Okay, actually here I have written wrong. It should be w y x z bar. Okay, in this way you can consider w x y z in this way. Okay, w x y z, with respect to that you can fill. Okay, so this is about the k-map technique. So in the next video I'll take one expression and I'll solve using the k-map.